In part C, we have 4 divided by x minus 3 plus 2x divided by x squared minus 9 equals 1 over x plus 3. You can't cross multiply as is. But the method I presented to you will work on this right away. We just need to find the LCD. So look at the denominators. We have x minus 3, x squared minus 9, x plus 3. What do we have to do in order to find the LCD? It wasn't relevant in the other problem. You have to factor the x squared minus 9, or factor any denominator that's not factored all the way, but that's only x squared minus 9. So here's what I recommend. Rewrite, I know you don't want to do this, but rewrite the entire problem with any denominator that's not factored, rewrite it in factored form. So how does x squared minus 9 factor? Okay, so x plus 3 times x minus 3, or vice versa, either way. And we get 1 over x plus 3. So, okay, up here in the corner, what's the LCD? Yeah, you just go through, you pick, it's got to have an x minus 3, it's got to have an x plus 3. This is the entire LCD right here, right? It's got to have an x plus 3. So one of each factor, so just, but no repeats, right? So x plus 3 times x minus 3, or vice versa, doesn't matter. That's your LCD. So you're going to multiply this left-hand side by that LCD. You're going to multiply the right-hand side by that LCD. By the way, we're really applying the balance principle when we do that, right? You have to remember to multiply both sides of the equation by the LCD. Okay, so now let's see if we can picture what's happening here. If I distribute this, okay, in this problem, I'll show you the step I would normally skip because it's the first kind of longer problem. But this step, you would normally skip this step because it's messy. And you can do it in your head better than you can, with a little bit of practice, better than you can if you write it out like I'm about to do. So remember what you do. When you distribute this guy, because it's really over 1, and because when you multiply fractions together, you multiply straight across, numerator times numerator, denominator times denominator, this guy lands in the numerator, either on the left or on the right. It doesn't matter. I'll put it on the right because I like having the 4 in front. It lands in the numerator right there. And you distribute it, so it lands in the numerator right there. So that when we rewrite this, so again, this is a step I wouldn't show. I'm going to rewrite the problem and then leave some room for it to land in the numerator. The right-hand side we can simplify right now, by the way. What's going to go away? X plus 3. So just x minus 3 times 1 is left, which is just x minus 3. Okay, now on the left-hand side, what I wanted to show you was the distribution. So when I do the distribution, this x plus 3 times x minus 1, the LCD lands as factors in both numerators. Is that x plus 3 times x minus 3, it should be. There we go. X plus 3 times x minus 3. Okay, it lands in the numerators. The LCD lands in the numerators. Now, can you see what's going to go away? Well, in this first term, the x minus 3's will cancel, right? Does everybody see that? Yeah? What about this term, the second term on the left side? The whole thing is gone. Does everybody see that? Okay, so then we end up with 4 times the quantity x plus 3. I'm not going to do the distribution right now. Plus what? Just the 2x, right? Equals x minus 3. Does everybody see that? Yeah.
I'm just confused on why, you don't make them common denominators.
And add them together?
Well, if it's x minus 3 in the bottom,
The goal is not to add the left side together. The goal is to clear the denominators. It's way easier to get rid of the fractions altogether than to add. Now, could you do it that way and then cross multiply? Yes. But the method I'm presenting to you is easier once you get used to it. It really is. And some students don't buy that, and they always try to use cross multiplication, maybe get common denominators and add those fractions together. But that's exactly what I'm not doing. I'm getting rid of those denominators. It's even better. But you have to get up that learning curve, and then it flattens out, and this method turns out to be easier than the one you were suggesting. The one you were suggesting would work. But try this method. In fact, I'm going to insist you try this method on the next test. Okay? If you solve one like this by adding the left side together using common denominators, even if you get the right answer, I'm going to say no. You got to do it the way I'm doing it here. Only because I have to force you to do things new ways. It's weird. It's a weird quirk of human nature that once we learn one way to do something, we don't like doing it another way, even if the other way turns out to be easier. It's harder to learn, right? It takes more brain power to do that. And as you get older, do you think you're more open to learning new things or less? What's your experience with your parents? You're probably a little less likely to want to learn new things as you get older. Try not to be that way. Try to be open to learning new things, and your mind will stay young. It really will. Anyway, that's my life advice for today. You don't have to listen to it, but you do have to listen to my directions here. This way is easier, trust me. Okay? So check it out. It's a linear equation, isn't it? You guys know how to solve a linear equation. What do you do here first? Yeah, distribute that 4, and what do you get? 4x plus 12 plus 2x equals x minus 3. Let's combine like terms on the left side. What do you get if you do that? Let me back off here. So if you combine like terms, we get 6x plus 12 equals x minus 3. All right, help me out here. Now, on opposite sides, we have like terms, right? So let's get the x's on the left side. What would that give us? Yeah. Go ahead.
How come it wouldn't be 6x squared? Why is it 6x?
When you're adding, you're not multiplying. Oh, okay. You're adding like terms, right? Yeah. It's like 4x plus 2x is like 4 apples plus 2 apples. So you don't want to have squared apples, do you? No, that wouldn't make sense at all. But no, if you were multiplying, you would have an x squared term, right? You'd have like an 8x squared, but you're adding. So that's not what you do. If we got all the x's on the same side, what would we do with this x? So subtract it, and you'd get 5x plus 12 equals negative 3. And then what do you want to do with the 12? What do you get if you subtract 12 from both sides? Negative 15. And then what do you get if you divide both sides by 5? Negative 3. Now, a big warning here. You can get, even though you've done nothing wrong, and I assure you, we've done nothing wrong here. Even though you've done nothing wrong, you can get wrong answers. Now, what do I mean by that? We don't really call them wrong answers. We actually call them, we have a big fancy word for it. They're called extraneous solutions. Even though we've done everything right, this is not going to check. I know it's not going to check, and I can figure it out really quickly if I go and look at the original equation. What happens, okay, if you plug in negative 3 in here, it's no big deal. You get negative 6 in the denominator. That's possible, right? You can divide by negative 6. But what happens if you plug in a negative 3 here or here? What do you get in the denominator? You get 0, because in the x squared minus 9, negative 3 squares out, right? And you get 9 minus 9, 0. In the negative 3 plus 3, of course, you get 0. You get division by 0. This guy does not check. You're not allowed to have division by 0. Now, where would it check? It would check in the equation where you, after you cleared the fractions, it would check in that one, but that's not the original equation that we're trying to solve, is it? So What you do at this point is you cross this out. It does not check. It doesn't check. It's an extraneous solution. Extraneous. And are there any other solutions to choose from here? No. So there's no solution to this thing. And for a lot of students, that depresses them because we did all this work and we get no solution. But no solution is an answer. There's no number x that would satisfy that equation. That's what we're saying.